next speaker, Dr. Jennifer Priestley, is the Associate Dean of the Graduate College and the Director of Analytics and Data Science of the Institute at Kennesaw State University. In 2012, the SAS Institute recognized Dr. Priestley as the 2012 Distinguished Statistics Professor of the Year. She served as the 2012 and 2015 co-chair of the National Analytics Conference. Datanami recognized Dr. Priestley as one of the top 12 data scientists to watch in 2016. Dr. Priestley has been a featured speaker at SAS Analytics, Big Data Week, Technology Association of Georgia, Data Science ATL, the Atlanta Chief Data Officer Summit, the Atlanta CEO Council, Predictive Analytics World, Informs, and dozens of corporate events addressing issues related to advanced analytics and the challenges and opportunities of big data. She is a member of the advisory board for the Southern Data Science Conference. She has authored dozens of articles on binary classification, risk modeling, sampling, statistical methodologies for problem solving, and applications of big data analytics. Prior to receiving a Ph.D. in statistics, Dr. Priestley worked in the financial services industry for 11 years. Her positions included Vice President of Business Development for Visa EU in London, as well as for MasterCard US and an analytical consultant with Accenture's Strategic Services Group. Dr. Priestley received a Ph.D. from Georgia State, an MBA from the Pennsylvania State University, where she was president of the graduate student body, and a Bachelor of Science from Georgia Tech. Please welcome Dr. Jennifer Priestley.
Thanks. Thank you. When I hear that, it just makes me sound old. But thank you for going through that. Yeah, so I spent 11 years in the private sector in the financial services space, and now I've been in academia for 14 years. I should say I started working when I was 6. No, just kidding. My students tell me I'm a lot more interesting if you're fully caffeinated, so hopefully you took advantage of the coffee break. Yeah, so I'm going to be talking about the evolution of data science because data science looks very different as an academic discipline today than it did when we first started having these conversations back in 2004, 2005. So, I want you guys to, that didn't come out very well. I want you guys to kind of think about for a minute, just kind of reflect. If you had to start a data science program from scratch in a university, what would that look like, right? What kind of coursage would you include at the undergraduate, master's, or Ph.D. level? And importantly, where would you house it? This is an ongoing conversation amongst academics in this space. So I pulled out this graphic that didn't come out very well. From Google Trends, and whenever I think about how something has evolved, right? When we think about how data science has evolved, I went to Google Trends to see what does this look like over time, and so you can see very clearly not over here. This really kind of starts around January 2004, which is when we first started having these initial conversations, and then over here, sometime around 2012, 2013. We start to see this hockey stick in terms of people really being interested in data science. This is when people would say, okay, on Friday, I was a poet on LinkedIn, and on Monday, I was a data scientist, hoping that they would get more job hits, right? And so what was actually happening at that point? So there were a lot of things happening. I mean, we could talk about the convergence of technology. We can talk about the convergence of all the different types of data, the redefinitions of data, the fact that the definition of what we even talk about as data was really continuing to change and transform in sort of meaningful ways back in around 2012, 2013. But if you were paying attention at this point, you probably also remember this is when the article came out, right? Tom Davenport, Harvard Business Review, that this is the sexiest job of the 21st century. So all the geeks that were studying math and stat and comp sci wanted to be sexy, and so they moved over to data science. And so that's why we're seeing that hockey stick. But lest we feel like we're important, again, this didn't come out very well, that's an overlay of searches on Kim Kardashian relative to data science. So, she kind of produces data in her own way, but anyway, there you go. Just in case you were thinking you were more important than you are. So when we really talk about this evolution of data science as an academic discipline, let's talk about where we were. And that'll help set the stage and maybe provide some context in terms of kind of where we are today. So I really studied statistics and decision sciences, as it was called back in the day, and applied statistics in the early part of my career. And it's kind of fun now to talk to statisticians because they'll say, data science. We've been doing data science forever. We are the original data scientists. And to that I say, not really, and let's talk about why. So, when we kind of look at the bottom side of this continuum, we can talk about data that is small, structured, and static, right? Small, structured, and static. And so when I was going through school, most of the data that I worked with was small, structured, and static. And this is the happy place for statisticians. Statisticians like data that's small, structured, and static. And this is where we get into, all these very traditional statistical concepts, right? We get into descriptive statistics and the basics of predictive modeling and classification. And all of that works great when you're talking about data that is small, structured, and static. But certainly as we get into this evolution of data, and the data is no longer small, structured, and static, now we're looking at data that is large, unstructured, and in motion, right? So now we're starting to talk about IoT data, and we're talking about, data that's coming in from social networks, and we're talking about text data, and we're talking about all the different types of data that I know is sort of a day in the life for most of you. And now these concepts that statisticians find to be in their happy place don't work anymore. This is where statisticians start to say, ooh, wow, now I've got an issue. And so kind of enter stage left, computer science, right? And so this is where we really start to get into this definition of what data science looks like, because these concepts related to descriptive statistics and predictive modeling and classification is still core and foundational, but it's not sufficient by itself with these new definitions of data and how data is continuing to evolve. And then as we, kind of continue up that continuum and we get to some of the things that Venkat were talking about, now we're getting into data that's massive and integrated and dynamic. And now we're talking about systems of data talking to systems of data. And really the basics of computer science don't even work anymore, right? So now we're starting to integrate statistics and mathematics, and now we're looking at computer science, and now we're starting to integrate more systems approaches, information systems, industrial engineering, physics, and then increasingly as we start to talk about human interaction with AI, right, and what that looks like, now you're actually talking about bringing in psychology and back to the humanities, which my friends in humanities just think this is the greatest payback of all time. That data science is now reaching back into the humanities. So the point here is that data science is this evolving discipline that looks very different today by definition than it did 10, 15 years ago. And so these programs that were originally launched at the front end of the data science evolution, they look very different. Hopefully they look very different than they did when they first launched. So let's talk about that. So, again, kind of going back into the 2000s, there really weren't many academic programs out there that really had this tag of data science or advanced analytics. And you can see sort of the explosion over time. And a lot of these programs are differentiating themselves as either being data science, or they're being analytics, or they're being business analytics. And that's important because all of these different programs are doing slightly different things. So let me talk to that. So you can see my disclaimer. I'm going to talk about how these evolve. So my disclaimer says any likeness to actual academic departments is unintentional, sort of. So when we talk about data science, we're really talking about bringing in mathematics, which needs to be part of the conversation, and statistics, and we definitely need to bring in the business school. They have to be part of the conversation, and we have to bring in computer science. And so I like to talk about data science from an academic perspective as sort of being this platypus, right? Because it has to integrate sort of the core concepts from all these different places around campus, and it doesn't neatly fit into any of these classifications. It is its own space, right? So, if you've never spent any time with a platypus, it's not a mammal, but it, produces milk, right? It has fur. And it's not a bird, but it produces eggs. And it's not necessarily a water creature, but it has fins and it has this duckbill. And so I like this analogy of the platypus. In fact, if we could just make the platypus the official mascot of data science, come on, go ahead. People are starting to clap. It's a thing. Can somebody tweet this? That we are the platypi, because I think it makes sense. And so we run an analytics and data science Ph.D. program at Kennesaw State. For those of you who might be hiding under a rock, Kennesaw State was the first university in the country to offer a Ph.D. in analytics and data science. Yes, you can clap again. Go ahead. So if we look at kind of now what's happening in the landscape, we spend a lot of time looking at PhD programs in particular, but I think that the distribution would probably hold for master's programs as well. So if you look at where PhD programs, and there's about 70 of them across the country, if you look at where they're housed, you can see the number one place that PhD programs in data science are housed is in what I like to call academic Switzerland. So these programs typically sit in a center or an institute or a graduate college. They are not predominantly sitting in computer science. They're not predominantly sitting in the business school. They're not predominantly sitting in mathematics. They tend to sit in these interdisciplinary spaces, which makes sense because they really need to draw conceptually from all of those different disciplines in some meaningful way. So, kind of coming back to this idea that these are interdisciplinary degrees, and they have to be treated in a different way than kind of traditional academic degrees. I love this definition of data science, or what is a data science, right, from Josh Wills. And it says it's the person who's better at statistics than any software engineer and better at software engineering than any statistician. And I like that definition because I think it kind of plays to those concepts, right? This idea that, data is no longer small, static, and structured, that we're moving into unstructured, massive, and in motion. But it takes the skills from both of those disciplines in order to really translate that into meaningful information to solve a problem, right? And then I think this overlay really needs to be incorporated into the conversation. And it's also the person who's better explaining the business implications of the results than a scientist, but better at the science than any business school graduate. And that was me, actually, that said that. But I thought it was brilliant, so I thought I'd go ahead and pull it in here. But again, I think it gets to this idea that when we talk about good data scientists that can come in and add value day one, we really are looking at that intersection of the business disciplines with the computational disciplines with the statistics disciplines. So that brings me back to to what's happening in academia and kind of what we're seeing in terms of working with the private sector. So, that didn't come in very well. So, we will have companies come to Kennesaw State, and they will be, let's just make some up, right? So we'll have, locally, we may have the Home Depot and Coca-Cola and Children's Healthcare of Atlanta all trying to chase the same kid. I can say kid because I just turned 51. Thank you very much. No, so we'll have these three very different types of companies chasing the same kid. And you might say, that makes no sense. Those are three completely different verticals, right? But the reality is, all companies, for the most part, are trying to do the same thing, right? They're all trying to take this massive data, structured and unstructured, right? Sometimes static, sometimes in motion, trying to take all this data and translate it into meaningful information to solve a problem. That's true whether you're talking about the healthcare sector, the financial services sector, the manufacturing sector, or anything in between. So what we find is that companies will come to us and they say, I don't necessarily need somebody who understands the energy sector. I need somebody who can work with the data. I don't necessarily need somebody who's a subject matter expert in finance. I need somebody who understands the data. I can teach them the content. I don't want to have to teach them how to think. I don't want to teach them how to work with data. I don't want to teach them to become data-centric. And so that's why we're seeing what I like to say is the employment equivalent of a run on the bank. That's why you guys are having so much trouble finding talent, right? If I went around the room and asked how many people, raise your hand, have an open position right now for a data scientist, it would be, well, everybody, because everybody's trying to chase the same talent at the same time. And so for the first time, you have the engineering sector and the marketing sector and the financial service sector and the healthcare sector all in competition for the same talent at the same time. And I can tell you that we have a shadow talent gap in academia as well, right? So if you look at people that are finishing PhDs in STEM-based disciplines, over half of them are now going into the private sector. I want you to think about that for a minute. Over half of the people in the United States that are completing a PhD in a STEM-based discipline are going into the private sector. That's never happened in our nation's history, ever. It used to be if you got a PhD, then you went on the track to be an assistant professor, an associate professor, and a full professor, and there you died, right? And you're laughing because it's true. So that's not true anymore. And so that creates some challenges for us in academia. Not only are, back to the idea that everybody's chasing the same talent at the same time, now we are in competition with all of your institutions and your organizations to hire people that are completing a PhD in this space, because we need that terminal degree for them to be able to be accredited to come in and teach, to produce the talent that then you guys need to create the pipeline, right? So we have this sort of cyclical issue going on. Thank you. And so this is a challenge at a couple different levels. What we see when we work with organizations is this concept of natives and non-natives. And when they come in the door, it has huge implications for the type of talent typically that they're looking for. So the organizations that are on the left are sort of those native organizations, right? Those organizations that were successful, long before we heard they're successful because of data that's large and unstructured and in motion, and they have to have that in order to be successful. But importantly, it's not about the technology. It's not about the evolution. It's really about the culture, right? That's what makes the organizations on the left different from the organizations on the right. The organizations on the left have data running through their DNA. They go to the data first, right? And then the technology and all the other things second. What we find is that the challenges for the organizations on the right, and some of them might be in the room, is that it's not about the technology. Most of these companies have the resources to be able to buy whatever the latest and greatest is that's being put forth by the vendors. Their challenges are cultural. Is really trying to convince senior management in some instances that we need to have a data-driven approach, we need to have a data-driven culture. And so when these organizations come into Kennesaw State recruiting for talent, we find that their needs are a little bit different, and that becomes an important strategy for us in terms of working with them and partnering for talent. So I'll go ahead and animate this. When we talk about the rise of a new discipline, this idea that data science, this platypus discipline is emerging within universities, it has a lot of different implications. And one of the big implications that we've been experiencing at Kennesaw State is really this concept of the center row there, the interdisciplinarity of data science. And going back to that idea that you really need to be integrating computer science and mathematics and statistics in the business school, because when we have organizations come in and they want to partner with us on research projects or on initiatives, and they're looking for talent, they don't say, I want a computer scientist. I want to hire somebody out of computer science, or I want to hire somebody out of marketing. They're like, well, I kind of need these skills. Well, guess what? Those skills are going to be this combination of all of these things. And so, what we see, and I've been talking with some of the other universities, is that there's an increasing movement towards interdisciplinary degrees rather than degrees that just sit in these silos, right? So specifically, I can give you an example at KSU at the undergraduate level. So we have an undergraduate minor in applied statistics and data analysis. And in this minor, the students will major in something. So they're majoring in marketing, or they're majoring in biology, or they're majoring in physics, or whatever it is they're majoring. And then they all come in together to take these 5 courses in data analysis. And they're learning this combination of R, SQL, Python, SAS. And then through those 5 classes, they're learning, again, how to translate data into information to solve problems. Well, something magical happens when you put a nursing major and an engineering major and a chemistry major and a psychology major together on a team. Because when they first get there, they're like, seriously, I've got to work with him? You're kidding me. But yet by the end, they actually learn a lot more from each other in terms of analytical problem solving than they do from us. And I think certainly most of you can probably attest to that when you work in your jobs, you're typically not working necessarily with people that study the exact same degree that you did, right? And so this concept of bringing students together in these interdisciplinary frameworks is not just what's happening today, but I think that really is truly the future of education, and that's being driven by data science. So the other dimension that I sort of had up there is this idea that partnership with the private sector is really becoming front and center with universities. Again, if you talk to some of the universities that were represented downstairs, they probably all had a story around capstone projects and working with private sector partners in order to give the students, opportunities to work with real data and real challenges and real opportunities. And I can't speak to that highly enough. When they make me the benevolent czar of all things educational, having some kind of experiential learning overlay into your degree needs to be core. That has to be part of a 21st century education. And also, we're seeing less federal funding for research, right? And so I've got a couple things up here. To be honest, I could put 1 million little blocks up here, although you wouldn't be able to see them, that really talks about all the different collaborative engagements that are happening across the country between the private sector and universities. Somebody brought to my attention, they're like, I love how you have the $240 million investment between MIT and IBM up there in little font, and you have the Equifax KSU for $75,000 right there in the middle. But if anybody wants to give us $240 million, I promise I'll put it in a bigger font. You can find me on LinkedIn. And so this is just a quick snapshot of, kind of one of our research labs. So we have this research lab with Equifax. Equifax has been an amazing partner for us. And I'm kind of running out of time, but I can talk more about this for anybody that wants to buy me a drink. But specifically, I think if you talk to Equifax, what they'll say, one of the benefits of these labs is the whole concept of a talent pipeline, right? It's the idea of setting up a lab on campus where students have an opportunity to build facility with the data. They have an ability to build facility with the culture and the climate and understanding what it means to actually work in that organization. And they, especially like master's students, right? Because master's students tend to spin through pretty fast. So they're working in that context for 12 months, such that by the time they graduate, that then becomes the typical candidate, right, that would be available to work immediately after graduation. So these partnerships are great on a couple different levels, but I think the talent pipeline is one that we hear the most about. So just in summary, in terms of partnering with universities, we find that entities tell us there's kind of three big benefits. So one is this concept of growing the talent. If you try to, all of you have open positions for data scientists. And if you go recruit off of the West Coast, or if you try to go recruit out of Boston or New York, and they come to Atlanta, we've heard that the retention tends to be low, right? So if somebody grew up on the West Coast, their family's on the West Coast, they went to school on the West Coast, most importantly, their girlfriend's on the West Coast, the probability of them staying in Atlanta for any long period of time is probably low. And so this idea of partnering with universities, and the great news is you got a lot of universities in the Atlanta area, right? Partnering with universities to grow the talent takes a little bit more time, but ultimately generates higher benefits. Alternate insights. So the great thing about working with a university is that typically the students don't know anything. So if you come in and kind of give them your problem, they don't have the baggage, right, of having worked in this industry for the last 10 years. So they have the opportunity to really look at your problems, look at your challenges with a very clear, clean set of eyes, and potentially provide insights in a way that you hadn't anticipated. And then this whole concept of screening talent, right? So you can only get so much out of an interview process, bringing in new talent, but to the extent that you kind of set up these university relationships and these labs, like a research lab, and then you see these students, even if it's in a capstone context, now you're looking at basically a 15-week or potentially 6-month, 8-month, 12-month screening process, right? Again, that typically gleans higher benefits than just going through a 75-minute interview. So I know I'm out of time, and that was a lot of words, and some of my slides didn't come up correctly. But that kind of concludes my remarks. I'm going to be around, so if anybody wants to talk to me afterwards, I would be happy to. Ultimately, I think I was a warm-up act for the guy from Texas A&M who's going to be talking about sports analytics. So I'm going to hand the clicker over to him. So thank you so much.